Okay, if you would, find this problem in your packet. It's on Inference Testing Day 3, problem number 2, page 116. And read through it and answer the 3 questions that I always ask. What type of data? What type of test or confidence interval? And what symbols we use for the stats given to you. Okay, so hopefully you read through this and realize this is categorical data due to the fact that people are answering yes or no, whether they agree to whether TV advertising is a good way to promote a product. This is an hypothesis test because I don't see the words confidence interval. And this actually has 2 different samples, and that's why this problem is a little bit different than the others. It's going to be a 2-sample test. So we're going to have 2 samples, p hat 07, which in December 07 was 622 out of 1,020. And then I'm going to have p hat in 08. The survey was redone in 2008, and then at that time it was 676 out of 1,009. So very similar data, but we want to see if there's enough difference here to say there's a difference in attitude toward these 2 questions. So one of the big things is to recognize this is a 2-sample test, and we're going to talk more about this as we go through this, what makes this one different than others. So let's talk about a 2-sample test. A 2-sample test is an example just like this where you're given 2 different samples that are different in the sense that the 1,009 adults that were surveyed in 2008 were not the same as adults that were surveyed in 2007. It was 1,020. Please note the 2 samples do not have to be equal. There's nothing that says they have to be equal, and in this case they're not, but they have to be 2 completely different sets of samples. There's another kind of test, which is called a matched pairs test, where you have the sample do the experiment twice. And that's a special case, which I'll talk more about with the next problem. But for this problem, we're going to limit ourselves to 2 sample tests. So this is a 2-sample test because I have 2 completely different surveys, 1,009 adults in 2007 and 1,020 adults in 2008, or vice versa. Okay, but they were not the same adults. That's the key to this. So this is a 2-sample test. So we're going to see how this works as we go through and do this problem. So let's take a look at the state. So remember in the state, you always had to write the null and alternative hypothesis. So you can see here, I wrote the null hypothesis using the notation P07 minus P08. If there is no difference between those 2, then when I subtract the percentages of people who say yes, I should get 0, meaning there's no difference between those 2 years in terms of whether they think TV commercials are effective or not. If there is a difference, then I expect it to not come out to be 0. Okay, and that's my alternative hypothesis. The percentage in 07 minus the percentage in 08 is not equal to 0. Please note I'm using P here, not P hat, because I'm trying to predict what the whole population looks like. The null hypothesis should always, the null and alternative hypothesis should always be about P or mu, never about P hat or X bar. I'm going to keep saying that over and over again as we do these videos. The other thing I want you to note is that the null hypothesis is always equals. So if you notice here, I use an equal to sign for the null hypothesis, and that's intentional. That will always be true. Oops, sorry, equals to sign over there. Okay, so the null hypothesis is always equal. The alternative hypothesis is always something else, either less than, greater than, or not equal to. In this case, it's not equal to. We just want to show there's a difference. We don't care whether it was higher in 07 or higher in 08. We just want to know that there was a difference. And there's an alpha level, which is the classic one, 0.05. Okay, so now let's go down to the plan. Okay, so the plan, our same three famous categories: random, normal, and independent. The difference is that we have to actually show that both samples are random, both samples are normal, and both samples are independent. So we actually have to make sure we mention that both of them, and that's why you'll see in both all 3 of these where the word both has been capitalized. So that's emphasizing the fact that we're looking at both samples. So random, we had to see that both samples are collected randomly. If you look back up here, it says, yes, they were surveyed randomly in 2007 and 2008. Both samples are categorical, so we have to look at the number of successes and the number of failures and see that they're both at least 10 for both samples. Well, that was true for the 2007 and 2008. We had 676 and 622. And then if you subtract the totals, 1,009 from 676 and 1,020 from 622, that tells us the number of failures, and that's where I got the 333 and 398. I subtracted those from the total number of people and found out how many people said no. Also, then I had to use the rule of 10 for both samples. Now, I did a little bit of a trick here. I took the larger of the two samples, 1,020, and I multiplied that by 10 and said there's 10,200 adults in the United States. That encompasses both samples that way, because a smaller sample would be 1,009 times 10 is 1,090. 10,200 is still bigger than that. So as long as we can say there's more than 10,200 for both, it covers both samples. So I do a little bit of a trick here just because I take the larger of the two numbers and just do the rule of 10 on that one, if that makes sense. Okay? So if you notice here, the plan is exactly the same. The only difference is that you have to check for both samples for random, normal, and independent. So now we get down to the do. We have the formula. So once again, in symbols and in words. Now I'm going to allow you not to put numbers for two samples because it gets very complicated. So you don't have to put numbers, but you do have to use the word. Sorry, I don't have it in words here either. Let me put that in there real quick. So this is where you have in words, z equals stat minus parameter over standard deviation of the statistic. Notice I use z because this is categorical. Reminder, we always use t when it's quantitative. Categorical. This is the formula from the formula sheet. So I copied that down, and then I punched in my calculator. I'm going to show you how I did that here in just a second. And I punched in and got my z statistic and my p-value. So I show you how that works on the calculator. You can see that I did it here, but I'm going to review the steps. We go to Menu, Statistics, Stat Tests. Now we're going to look at the two sample tests. And remember, we never do number 1 and 3. I keep emphasizing it over and over again. Never do that because we never have the standard deviation of the whole population. So in this case, we're going to do a 2-prop z-test because it is categorical. Prop means proportion. And z meaning, because that's what the variable we're using there. That's what we use for categorical. So use a 2-prop z-test. And then we type in our values. So I'm going to type in say 676, and this is the 2008 data, so 1009, 1009, and then for 2007 it was 622 and 1020, and we're going to keep it not equals because we don't care whether it's smaller or bigger, we just want to know that it's different. And we hit OK, and you can see that's where I got my two values. These are the two values that we need, the z and the p-value. All the other numbers here are just values that are part of the process, but you don't need to record those. So you can see I record those two values. So then, based on that, I can make my conclusion. So since the p-value, is 0.04, up here you can see, is less than our alpha level, 0.05, we're going to reject the null hypothesis. That's the fancy way of saying we're going to say the null hypothesis is probably false, which means that there's a difference in dull opinions about the effectiveness of TV advertising from 2007 to 2008. There's the context. And this is what we do to solve these problems. So again, this is a 2-sample test, something different than you've seen. But hopefully this will help you out as we do problems like this.